Hello, math scholars. It's October 1st. Who's excited?
October pumpkin!
Yeah. Who's ready for the joke of the day?
Me.
Okay, what do you call it when your family has a bunch of math nerds? What do you have when your family has a bunch of math nerds? Square roots.
Oh.
I get it. Your roots.
Yeah, that's a good one.
That was good. He claims he just thought that one up. I kind of liked it. Well, happy Monday. Hopefully you had a fun weekend, whether you went to homecoming or not. We're doing 2.1. We're finally in a new chapter, so that's a reason to be excited enough. So 2.1, we're using properties of exponents. The kids in class did receive a little piece of paper with all those properties on it, because there's a lot of properties. How many properties are there? 1, 2, 3, 4, 5, 6, 7 properties. So it'll save you some writing today, definitely, by having those taped in. Just keep passing those tapes around. So here's your properties. If you are at home, just be aware these are on the slides that contain the notes, and I put those notes as PDFs in Polaris. So let's start with product of powers. Product of powers. You can kind of look on your little slip of paper, but so the definition on the slip of paper is a to the m power times a to the n power equals a to the m plus n. So you basically are going to take your bases, keep that base the same. In this case, 5 to the third and 5 to the negative first. You're going to keep that base of 5. You're not going to make that base of 25, although it's tempting. But then you're going to add the exponents. So you'll just do 3 plus negative 1, and that would be 2. So our final answer is 5 squared. And if it's a small enough number for you to calculate, go ahead and calculate it. Now, if it was like 5 to the 17th, I probably would just leave it 5 to the 17th. Not want to write out a huge answer. All right, the second one here, it's x to the 7th and x to the 5th. So once you realize both of these have that same base of x, you can keep your base in x. And you can take your exponents and add them together. So I would just do 7 plus 5. 7 plus 5 is 12, and that's your final answer for this one. Have you seen these exponent rules before?
Yes.
Perfect. Last year or 2 years ago?
I don't know.
Don't remember.
I think last year.
I love it when those geometry teachers throw in some algebra just to keep you fresh. So that's why I was curious.
Yeah, they did it last. Our teacher said that she was going to do that last year for
Good.
the reaction of
Mr. Poland didn't do it.
All right. Anyways, we are going to go ahead and try this next one. It's starting to get tricky. You don't want to treat the normal everyday numbers the way you're treating the exponents. So see this like 12 and 3? They're just normal everyday numbers. And if you're multiplying normal everyday numbers, you'll do 12 times 3. So what's 12 times 3? 36. So people will accidentally do 12 plus 3 because that's what you'll go do with the exponents, but we're just multiplying because they're normal numbers. Now the exponents we're going to treat as exponents and use exponent rules. So in this case, since these bases are separate, I can combine them into a single base and make it x to the 13th. So I want to show you visually what something you could have been allowed to do if it would have helped you see it better. Don't you guys agree with me? There'd be a little dot between the 12 and the x squared. And there'd be a little dot between the 3 and the x to the 11th. You can rearrange this. So you can put your 12 and 3 beside each other, and you can put your x's beside each other, if that lets you see the situation better in your head. See that? You're always allowed to rearrange because you're allowed to multiply in different orders. But 36x to the 11th. Okay, so I think that might be it for that property. Let's do a different property. We're doing power of a power next. Looks like it's the second one on your little sheet.
Are we learning all these today?
Yep, I think so. Okay, so this first one at the top, it's actually the exact same example that's on the little sheet. I just remember next door buddies. I see these two as being next door buddies. They're literally right beside each other, and next door buddies will multiply together. So let's multiply our next door buddies. 3 times 2 would be 6. So it'd be 3 to the 6th. Now 3 to the 6th is a large enough number I can't actually do mentally, so I'd be fine with you leaving that. If you want to type it in the calculator, you can. It looks like on the little sheet they got 729. And then the next one. So I have this 12 and this 4. They're definitely little next door buddies, so they're going to multiply together. What's 12 times 4?
48.
48. And that's your answer to that one. power of a product. So in this case, there's a product, meaning there's two things being multiplied. They're in parentheses with the power on the outside. Basically what happens is that power will just distribute in and everybody will get that exponent of 4. So 2 will get his own exponent of 4, and 3 will get his own exponent of 4. I probably would go ahead and just calculate out what that is, because it'd look weird leaving it like that. 2 to the 4 would be 2 times 2 times 2 times 2, 4 times. So 16. And then 3 to the 4th is 3 times 3, 9 times 3, 27 times 3, 81. But yeah, I would probably just type it in and see what the overall answer is. 1296. And they actually have it on the paper. 1296.
You want to actually answer for this one?
Yeah, because having one number to a power is one thing, but leaving two numbers to powers, it's weird. I don't know. Up to you. Alright, number 2. Same exact thing. This 3 will distribute into everybody. Now there's a 5 right there. Do you remember what will happen with the 3 and the 5? Multiply, so it'll be m to the 15th and y to the 3rd. And then on this third one, it becomes very important to think about which are exponents and which are regular numbers. So I take this 2 and apply it to the 3. Will I do 2 times 3, or will I do 3 squared? Good. Huh. So it's actually 3 squared, which is 9. So I'd write that as a 9. The 5 and the 2 will multiply. They're both exponents. So it'll be a 10. The 4 and the 2, they'll multiply. They're both exponents. It'll be an 8. So my final answer, 9 m to the 10 n to the 8. We've arrived at our next property, the negative exponent property. This is my favorite because I have a little bitty song that I like to sing for this. Ready?
Yeah.
So if you see a negative exponent, here's what you have to do. Flip and make it positive. And if you swing your arm, it'll make it more fun. So say that with me and swing your arm. Flip and make it positive. So here's what I mean by that. What I'm saying by it is the exponent itself. So you're going to flip the base. So I'm going to flip that 7 to the denominator. By the way, the 7 is called the base, and the negative 2 is called the exponent. So you flip the base, and you make the exponent a positive. That would just be a little too wordy of a song. Flip the base and make the exponent positive. It's hard to say. So I just say flip and make it positive. And then I'm just going to go ahead and figure out what 7 squared is. It's 49. So that's your final. 7 to the negative 2 is 1 over 49.
Are we allowed to put it in decimal form?
Let's just go with fraction for this one. Let's do the 0 exponent. Try typing this in the calculator just for fun to see what happens. You might know, you might not. Most people think it's 0. It's actually not.
Is it just...
It's 1. How do you know? Do you look at the paper or you know? Anything to the 0 power equals 1. It's shocking. You would think it'd be 0, but it's 1.
Why?
Why? I don't have a super good explanation other than showing you a pattern. I'm going to go ahead and make myself a t-chart for x and y. And my equation is going to be y equals 2 to the x power. So let's start with 1, 2, 3, 4. So I'm going to put a 1 in for x. What's 2 to the first power? I'm going to put a 2 in for x. What's 2 to the second power? Put a 3 in for x. No. 2 times 2 times 2. 8. And then 2 to the fourth power? 16. So if we're going to go backwards, I'm going to show you the pattern that's developing. If I do 16 divided by 2, I'd get 8. If I did 8 divided by 2, I'd get 4. If I do 4 divided by 2, I get 2. And if I would do 2 divided by 2, I would get 1. And so anything to the 0 power equals 1 just kind of keeps that pattern going. Every t-chart you ever would make would have a pattern. A 0 right here wouldn't fit that pattern. Okay, so the best explanation I can show you. See that? Interesting, I know. Super cool. Oh, all right, quotient of powers. Quotient of powers.
Are we going to get this formula sheet on the test?
No. After you practice a million of these, you'll just know the patterns. They'll be second nature to you. All right, so they kind of tricked us in this one, and they put a couple negatives. I guess we need to do a flip and make a positive situation. So if I saw this first problem here on the top, I would say, ooh, negative exponents. Not a fan of those guys. So I'm gonna bring my arm, flip and make it positive. So this one, for example, the 6 to the negative third is gonna flip to the bottom and become a positive 6 to the third. And then the 6 to the negative 6 is gonna flip to the top and become a positive 6. So let me kind of explain what is actually going on here. What's actually going on is I have 6 sixes living in the top. 1, 2, 3, 4, 5, 6. I have 3 sixes living in the bottom. 1, 2, 3. And then they'll cancel top, bottom, right? How many will cancel? 3 of them. So I'll have 3 of them left at the top. 6 to the third. It looks like they probably typed it in on your sheet. What is 6 to the third? 216. Yeah. So I'll show you every single time. You're not going to write them all out and cancel them out. So I'm going to show you the shortcut. It's called bigger minus smaller. Put the answer where the bigger lived. It's a little song. Bigger minus smaller. Put the answer where the bigger lived. So you take the bigger exponent, the 6. You subtract off the smaller exponent, 3. 6 minus 3 is 3. And you put that answer where the bigger one had been, which is up in the numerator in this case, up top. Does that make sense? So let's look at this one as an example. If I would do bigger minus smaller, I would do 15 minus 13. Do you agree?
Yeah.
But put the answer where the bigger lived. In this case, the bigger one, the 15, lives in the denominator. So that answer of x to the squared is going to be in the denominator. It just basically means 2 more x's had lived in the bottom, and all the rest would be able to cancel out.
It's really short slides. Really short. We're almost done with all of them already.
I know, that's what I mean, because he was like, are we doing all these properties today? Yeah. Where it gets hard and challenging is when they take all the properties and throw them all together on a problem. So tomorrow we're actually just going to play speed dating, and everybody will have a card with problems on, and we'll just see a whole bunch of these. 30 different ones, you know? My favorite. Let's try this one. So when I say bigger minus smaller, are we going to want to do 10 minus 2? No way! 10 and 2 are normal, everyday numbers. You just divide them like you normally would. So I would do 10 divided by 2, and I get 5. But it's the exponents you can do the bigger minus smaller trick. Bigger minus smaller, 3 minus 2 would be 1. Put the answer where the bigger lived, that would be up top. So my final answer is 5x to the first. You could just write 5x. You don't ever need to write x to the first. Okay, I think it's the last one on our sheet. We made it through the list quickly, but then we're going to look at problems where they put all the properties together in one big math problem. So power of a quotient is very, very, very similar to the one we saw up at the top, power of a product, where you just have that power kind of looming on the outside, and it will distribute into everybody. So that 2 will distribute into the 4 and the 7. 4 squared is 16, 7 squared is 49.
Ooh.
That was the example, actually, that was on the little sheet, I guess.
Why are there so many problems for homework?
Because they're so quick and easy. Like, how long did that take me? Maybe 3 seconds?
Okay.
These aren't like the quadratic formula problems.
3 seconds is a little, like, exaggerated.
I'm just saying, if this right here, what I'm looking at right now is a homework problem, how long is it going to take me?
About 30 seconds.
Way less than that. The 5 will go here, the 5 will go here, x to the 5th, y to the 5th. I'm done. That was not 30 seconds.
Well, that's you.
Oh, man.
Right now.
Alright, so this is just a mix and match. Each one is just one single property, but I'm not telling you what to do each time. So, number A, if you raise your hand and give me the answer, you can have 1 ticket. Let's go with Izzy. Good. So this property, I never flat out ask you guys to tell me what property it is, but since we're new at it, let's identify it. This property would be called product of powers, where you just add them. Okay, part B. What would you do here, Nathan?
Multiply 6 and 4 to get m to the 24.
Good. And since we're new at that, let's identify the property as the power of a power. All right, and then part C. What would our answer look like? Let's go with Cecilia. Now, where are you going to put that m to the 8th? So I'm going to sing you a song. Bigger minus smaller, put the answer where the bigger lived. So 20. Yeah, 20 is bigger than 12, so she's going to put her m to the 8th on the bottom, and she'll just have a 1 as like a placeholder up top. Look good?
Yeah.
20 minus 12 equals 8. Put it in the bottom.
Go, Cecilia.
Hilarious.
All right. Beware! Beware! These are going to start getting bigger. And the biggest mistake I see students doing are treating the coefficients the same way they treat the exponents. You want to treat your coefficients like normal everyday numbers and treat your exponents with the exponent rules. So, Aaron, you want to try part A?
30 to 11.
Good. So he did his 10 and his 5 multiplied by his 2 to get the 10, but then the 4 and the 7 add together to give him his 11. Okay. Who would like to try part B for one ticket? It technically would be called power of a product, yes.
Okay, I can do that one.
All right, Logan?
These 3 times to the 4th.
So 3 to the 4th.
M to the 8th.
Good.
And then N to the 4th.
Good. And since 3 to the 4th is kind of a smaller number, let's figure out what it is. No, 3 times 3 is 9. 3 times 3 is 9. 9 and 9 is 81. 81. You did. When you said 27, you did 3 to the 3rd.
Yeah.
You're just missing 1 3.
Whoops.
Oh, the problems are starting to get bigger. Whoa.
Oh my
Can
god.
somebody do that for 5 tickets?
No, don't panic, anyone. It's not actually that hard. We'll do it together.
I didn't get my ticket.
Okay.
Yeah,
Stay calm.
He didn't get his ticket.
Stay calm. All right. So we're going to start with that 20 and the 4. Those are just normal everyday numbers, right? So what's 20 divided by 4? 5. Okay. Now let's deal with the P. So we're just looking at the P's. We're looking at nobody else, so we won't get confused. Bigger minus smaller. Put your answer where the bigger lived. So where's your bigger live? The denominator. So you'll do 18 minus 12. What's 18 minus 12? So p to the 6 will live in the denominator. All right, what about our r's? Where's the bigger one live? In the numerator. So you'll do 14 minus 8. Get 6, so r to the 6 will live in the numerator. Okay.
Doing the top one.
All right, I kind of forgot they included scientific notation in this section. This should be fun. Everybody groaned because I think they are scared of science class for some reason. But which one of these two choices is in scientific notation? There's only one, believe it or not. They both look like they are. It's the first one. Good job, Carly. Why? No, she just guessed. Scientific notation. You're only allowed to have one digit to the left of the decimal point. So that 1.3 times 10 to the 7th, that's scientific notation. Now this one, if I want to put it in scientific notation, I need to make it 2.845 times 10 to the, since I made it smaller, I think that's going to make it one more smaller to the negative 6. I have to type it in just to make sure that works. All right, I did type it in. I actually had made a mistake. I counted how many places I'd have to move my decimal point, and it was only 4 places. So it's 2.845 times 10 to the negative 4th. Now you're probably wondering, what is she looking at on that calculator screen? What I did is I typed in 28.45 times 10 to the negative 5th, and here's what I saw on my calculator screen. 0.0002845. And I just pictured moving that decimal point from where it's at now over to here, and I counted how many movements that would be. 1, 2, 3, 4. 4 movements. So it's 2.845 times 10 to the negative 4. Okay? Can you ring in a bell? What grade do you originally learn this stuff in?
I feel like I've learned it.
Like 8th grade, 9th grade?
I feel like I've
Don't even
learned
remember.
it like in school, but
Okay, so the next one, my advice was just do the 4.2 times 10 to the 3rd on the calculator and multiply it on the calculator times the 1.5 times 10 to the 5th. Oh, 10 to the 6th, sorry. Hit enter. My calculator screen showed me 6, 3, 0, 0, 0, 0, 0, 0, 0. I counted 8 zeros. So then we talked about how to be in scientific notation, you need one decimal, one digit to the left of the decimal point. That would be your 6. And we're going to count how far the decimal point would need to move. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is a little crazy. That's probably what I would have expected, seeing the 10 to the 3rd and the 10 to the 6th, for them to add up to 10 to the 9th. It's kind of like a cross-reference check. Isn't that cool?
I don't like this anymore.
You don't like it anymore, why? Let's try the next one in the calculator. 6.3 times 10 to the 5th multiplied by 8.9 times 10 to the negative 12th. On my calculator screen, I'm seeing 0.0000 five zeros, and then 5607. So, do you know where a decimal point would need to go for scientific notation? Between the 5 and 6, because we want one digit to the left of the decimal point. One digit that isn't a 0, that is, to the left of the decimal. So I'm going to count how many movements I need. 1, 2, 3, 4, 5, 6. That's going to be a negative 6 times 10 to the negative 6 because I moved to the right. So that was fun. Put you back into chemistry for a minute. All right, well, we're going to go ahead and call it a day to give these kids some homework time to work. You should have a textbook under your seats. It's page 91, 2 to 38 even. Thanks for watching the video at home.